सो फर्स्ट ऑफ ऑल सबको बहुत बहुत शुक्रिया, धन्यवाद आप लोग टाइम निकाल के हमारे यहाँ टाटा आईएएस के वेबिनार में जुड़े हैं आज। सो थैंक यू सो मच फॉर ज्वाइनिंग टुडे। वी होप नेक्स्ट जो 1 घंटा रहेगा आपके लिए बहुत यूजफुल रहेगा, आपको कुछ नया सीखने को मिलेगा। So Vibhuti and Senthil, two seasoned experts in the field, they have prepared two demos today, which will help you learn more about basic robotics and enhance your skills. Anyone who is a student या फिर कोई ऐसा है जो अभी पढ़ रहा है या पढ़ा रहा है या फिर हो सकता है वो लोग ऑलरेडी कहीं नौकरी कर रहे हों, देर ऑलरेडी वर्किंग, किसी के लिए भी है या कोई टेक एंथुसियास्ट है जो रोबोटिक्स के बारे में और सीखना चाहता है, सबके लिए ये वेबिनार बहुत यूजफुल रहेगा। सो आई विल जस्ट गिव अ शॉर्ट इंट्रोडक्शन जो हमारे स्पीकर्स हैं। मिस्टर सेंथिल कुमार, he has more than 9 years of experience in installation of universal robots and robots. He also has expertise in ROS and computer vision, OpenCV, and he's also our beloved trainer at Tata IIS, and he has been doing an exceptional job. We have trained multiple batches till now in automation and robotics. Then we have Vibhuti. He has 17 years plus of experience in the industry, and he has been associated with Tata IIS for more than 2 years now. बहुत सारे ट्रेनीज को सिखा चुके हैं, and he has been a very dear member in the team. Before Tata IIS, he has also worked with big renowned organizations like ABB and KUKA, जिनके ऐसी कंपनीज है जिनके रोबोट्स एक्चुअली अभी हम अपने लैब्स में भी फीचर करते हैं बिकॉज दे आर ग्लोबली रिकॉग्नाइज्ड ब्रांड्स। सो ओवर टू यू गाइज नाउ। This was a brief introduction about how we are going to go ahead today. So this is for audience. एक बार जब speakers का session खत्म हो जाएगा, आप लोग अपने questions chat box में लिख सकते हैं, and one by one we will try to answer all the queries that you guys have. Okay? एंड इफ रिक्वायर्ड अगर किसी को कुछ बोल के पूछना है तो आप रिक्वेस्ट कर सकते हैं कि अनम्यूट करा जाए आपको, और हम लोग आपको अनम्यूट करके वी लेट यू इंटरेक्ट विद द एक्सपर्ट्स। ओके, ओवर टू यू सेंथिल।
Yes, thank you, Srishti. My voice is better, right?
Yeah, we can hear it.
Okay, yes. So thank you everyone first for coming on Friday evening to attend this webinar. So we are starting with the first collaborative robot simulation. So I'll just share my screen. So I hope you are able to see my screen.
Yes.
Okay. So before starting with the product, first I want to give a small introduction about the, I can say like what product we are going to see. So the brand name is called Universal Robots. They are the first two people to develop collaborative robots and to start with like last 10-15 years they are in the market and they're doing really good. So they have like different kinds of products. Example, you can see here under Cobot's E series, particularly that is the recent version they have launched. Under that E series, if you go through, you can see like UR3E, 7E, 12E, 16E, and other products also they have. So what is the main advantage of collaborative robot is like it does not require any like safety fences when the robot is working. Collaborative robot is again an industrial robot, but it is having lot of safety functions inbuilt. So that is like playing a major role when any company is installing in their premises, because safety is very important for any applications you are developing under automations in any company. So this is like a very important product. Example, you can see this UR3E. I'm just clicking, it will just open, and you can see the reach of the robot is 500 mm and it is having footprint of 128 mm. So this footprint is like very small, even I can say like less than an A4 sheet. So you need, this robot is like a tabletop robot. So you can just mount it on any table and you can use it without any problem. And the payload, it is having 3 kg payload. So, and the entire weight of the robot is just 11.2 kg. So this 11.2 kg, it is having 6 servo motors inside, and it is having lot of cables, aluminum pipes, and it is having aluminum casting, plastic caps, everything. But still the weight of the entire robot is just 11.2 kg. So this is the advantage of collaborative robot. Daily, if you want to deploy in different applications in different shop floor lines, it is possible with this robot. If you need more information, you can just go to this downloads where you can find about the data sheet. If you click this data sheet, you will find complete information about the product where you can understand like what is this robot actually and how to use this robot in your shop floor. So now coming back again, today's topic is more about like simulation software. So again, you can just type in the Google Universal Robots Offline Simulator. So if you type like this, the first link you can get from the Universal Robots official website. It is called Offline Simulator. So there you can find it is for non-Linux. So this software is basically for Linux version also available. Non-Linux version is also available. So mostly all the users in general, I can say Windows users are like very high. So if you are a Windows user, you need to download this non-Linux version. But if you are a Linux user, you can easily go for this, which is like very easy. So since I'm using Windows today, I'm just clicking this link. So it will open a page like this where you can find one WinRAR file at the bottom. So this file will explain you how to download it. Basically, if you click it, it will start to download. It is like 750 MB of file. You can use it with normal internet, not a big problem. And if you scroll down, as I informed, since this is for non-Linux operating system, we need to have some virtual machine. So what is mean by this virtual machine is using this virtual machine, we can run Linux operating system inside a Windows operating system itself. So that is the advantage. Since I am a Windows user, but I want to run a non-Linux, Linux software. So I can use Windows operating system as a default one itself without installing a Linux OS. Just I want to have one virtual machine where I can just drop the file. It will work without any problem. So for this virtual machine, Universal Robot is giving two suggestions. One is called VMware, another one is called VirtualBox. So this VirtualBox is like completely free to use. So I prefer that. But still, if you want to have VMware also, you can download that. So this need to be downloaded separately. Then at the bottom, they have explained about the system requirements on all the other things. This is like a self-explanation. You can just read it by yourself. So now once you downloaded these two files, it will be coming like this. You can see VirtualBox I have downloaded and URSIM virtual, which is non-Linux version I have downloaded. Okay. So this file is more like a very simple file. If you just open it, you can see it is just 105 MB. So if you double click, it will just open and you need to keep on click like next, next, next. And if you click finish, it will install in your system. And this is basically a zip file. So you need to extract everything. Once you extract, this is the folder you will get. So if you open this folder, you can find lot of files are here. So just leave it as it is, no problem. Now I'll just open VirtualBox. So in the VirtualBox, you can see there is a plus symbol, add. So this add, if you click, what will happen? It will directly take you to the place where you have downloaded the files. For you, maybe it is in downloads. I have particularly pasted it in a folder which is very suitable for me. So it is coming like this. And now if I'm double clicking this, you can see like some files are default, it is coming here. You can choose a file and click open. So the moment you are clicking open, it will get add like this. Okay. So I have done all those things because it will take some time. I don't want to delay in this webinar. So I have done all those things prior to this. So if you have any doubts or anything, you can always let me know. We can clarify that. So now you can see this file got added here. So what I'm going to do, just click start. So I'm using a Windows operating system. Now what it will do, it will open the virtual machine. Inside, Linux software will open and it will try to run the simulation. It will take few seconds. So you can see VirtualBox. Yes. So now you see this Universal Robots software name is called Polyscope. It got open and I'm having choices like which robot I want to choose. As I informed in the website itself, they have like different variants. So UR3, UR5, UR16, UR20. For today's demo, I'm just picking UR5, but you are allowed to pick anything you want. So what you need to do, you can see this icon and there is one program folder. So this program folder is like anything you want to save the files, it will be saved. As of now, we didn't save anything. So you need to just click this icon. So just double click on this. It will take again few seconds to open it properly. Yeah. So now you see 5.12 is the version we have downloaded, and it is designed and built in Denmark, and software name is called Polyscope. So it will take few seconds to load properly. So once the software is loaded, the first thing we need to verify is like whether the robot is in good condition or not. So now you see the robot UI got open. This we cannot make it like bigger size or reduce the size. It is like fixed size. So this software is the same software if you are buying the universal robot. So basically without buying the robot itself, you can actually use this software, which is like completely free to use, and you can learn the product 100%. So this is like a very good advantage comparing to all the other competitors. So now the moment I am switching on, you can see there is a red color indication saying power off. I'm just clicking here. It will open a particular small tab where it is mentioned power off. Also, it is asking me to on. So I can click on. It is telling booting complete, and you can see a robot is visible here. So again, I'm switching off. You see there will be no robot. So this particular space is for the 3D representation of the robot in real time. So again, I'm clicking on, you see the robot is visible. So now the robot is active, but still the brake is not released. So now what I'm going to do, again, click start. You can see all the tick marks got okay, which means robot is very good condition. And at the bottom, you can see it is telling normal. So which means robot is very good to start. And if you mount any gripper or something, you need to add the payload. Example, if you mount a 2-finger gripper, vacuum gripper, or welding torch, anything, you need to just add the payload here. Right now, it is just the robot, so you can just leave it as it is. Exit. So now this is the second screen you are getting, where you can see it is asking three options, whether you want to run a program or program the robot or configure robot installation. So run a program is more like once you complete the entire program, you need to go to the page. So now what we are going to do, program the robot. So if you click this icon, you can see on top, run, program, installation, move, IO, log. So since I clicked program option, it reached this place. But if you click run, it will directly go here. If you click configurable page, it will go to installation. So these are the three options available. Anytime you can change after clicking the options also. So first we need to understand how to move the robot. In general, this term is called jogging in robotics particularly. So now it is having three options under feature. I'm picking particularly base, which is like very easy for the beginner to understand. So if you watch closely here, it is giving three colors, and you can see the same color is representing here also. Example, starting with this green color, red color, and blue color. Same color you can see, green always represents y-axis. Red always represents x-axis, and Z always represents blue color. Okay, so these are the three which are like fixed when you're using base coordinate system. And now this axis, it is projecting towards this side, right? So this is called positive direction, which means if I'm clicking Y positive, you can see robot is moving towards back. And if I'm clicking Y negative, you can see it is moving towards the other direction. So this graphical representation, again, you can rotate as you want. Okay. So whenever you prefer, like you want to zoom, you can do. If you want to zoom out, you can do. And if you want to pan like front or back or something, that also we can do. So for the moment, what I'm doing, just making it little bigger so that it will be easy for me. So now I'm just clicking Y negative. Again, it is going forward. Y positive. Again, it is coming back side. So now if I'm pressing the X axis, again, you see this is represented as positive direction. So if I'm pressing X positive, it is moving towards us in the screen. And if I'm pressing X minus, it is moving in the opposite direction. Okay. And now the last option, what we are having is Z plus, which will make the robot to move up, Z minus, which will make the robot to move down. So all these things are working with respect to the base of the robot. So if the robot base is mounted in different direction, based on that, it will keep on change. So example, you can see the robot is facing towards this side. So all the axes are like this. And now if the robot is placing in a different way, so based on that, the axis representation will change. But anytime you can use these arrows to confirm. Okay. So now moving forward, you have one more option, which is like individual joint control. So if you want to control any one joint, so this robot is a 6-axis robot. So if I'm clicking only base, which is the first joint, you see only this particular joint is moving. Again, only one joint will work. So the difference here, everything is in everything is in degrees. Okay, you can see the annotation here itself, it is mentioned degrees. And now if I'm pressing Z plus or Z minus, it will always move in linear, which means mm. So this is a very big difference. Now based on your requirement, you want to move in degrees, you can always use any of these joints. It will get rotate only that particular joint. And if you prefer to have linear movement, you can always use TCP position. So anytime if I'm pressing these arrows, you can see only one joint is moving. Wrist 2, last wrist 3. So the only tool tip will rotate. The entire robot will be in the same place, but only the tool tip will rotate. And now if you want to move the robot to the home position, you can see there is a home button available here itself. You can just click it. You can see the robot is in currently the bottom and it is telling it will go to this position. Now you need to confirm whether it is okay or not okay, because as long as you are pressing it, the robot will move. If you take your hand, it will stop. Again, it will show the just how it is going to reach there. So you need to press continuously to reach to the final point. Okay, now it reached here. Just click continue. You can see the robot is in full straight position. So now again, if I want to move to any place, just click exactly which joint you want to rotate. For me, I'm just rotating elbow. So this entire learning without the actual robot we can do. So that is a very big advantage, I can say. Yes. So now you can see the robot is in like particular position, which is very comfortable to start programming. So if you want to do programming, just come to this program page where you can see this move button first. If you click this move, it will ask you to create a move command. So this is like a program tree where entire program will be created. So now if you want to create anything, just click waypoint 1. So waypoint is basically it will store all the 6 joint values in this particular place. So if you want to set this, just go to set waypoint. It will open this page. Again, if you want to use with base, you can use. If not, you can use the other two coordinate system also. For today's webinar, we'll stick with only base coordinate system. So now, if you assume this is my first position, which I want to save, just click OK. And here it is giving a name which is called waypoint 1. So this waypoint 1, if you are not comfortable, you can always rename. Example, click like this and you can put home underscore pose. So this is my home position I want to save. Just click submit. And now again I want to add one more point. I'm just clicking waypoint. You see this yellow color is coming, right? Which means it is a incomplete program. So since we didn't set this point, it is in yellow color. But if you see the last point, it is in normal white tone, which means it is already having values. So now again I'm clicking this set waypoint. You see this is my current position, right? So from here I'm just moving down Z minus, Z minus, and this position is comfortable for me. I'm clicking OK. So you see now there is no yellow, which means we have saved the point. So this particular point I want to rename again, pick pose. So this is the custom name you can create as per your requirement. Again, I want to create one more point where the robot is going to move either in left or right direction. So let's stay with maybe right direction. So Y positive, I'm clicking. Yes. Just save this point. It will be done. So I'm just saving this point. Example, right pose. Again, click waypoint. So now you need to create one more point. For that, I'm going to move in X positive. So it is moving towards front side. I think this is okay. Just click OK. Again, rename. I'm going to give this as front pose. So you can see I have created a lot of points now. If I want to again copy and paste any points, instead of again moving the robot to that place, again create waypoint, we should not do all those things. You can just click the point, right pose, and you can see at the bottom it is having cut, copy, paste. So we want to just copy this point, click here once, front pose, click paste. Same point it will repeat without any problem. Again click pick pose, copy, where you want to paste, just click paste. Again, which point you want to do? Home. So I'm just clicking home, copy, and you can just paste it. Now, if you feel like this point is not required, you can just click delete, it will be deleted. So again, if you want to do, either you can copy and paste, or you can see there is a undo symbol. So if you click undo, the point will again come back. So this is like a very easy user interface to create your program without any complications. So now there is a graphics tab here. Okay. So far we used only the command tab. Now I'm clicking the graphics tab. So here you can see the robot. What are the points we have created? Everything got recorded. You see, I'm rotating in 3-dimensional. You can see from top, it is coming here. Then second point, third point, fourth point like this. So what I'm going to do, I'm just pressing play button. So it is asking two options, play from the beginning or you want to start from where you are stopping right now. So I want to run from the beginning. So I'm just clicking play. So it is asking me move the robot manually to this place. I'm moving. It is moved. So now it is giving a warning, stand clear of the robot when you press play. Since we are using simulation, we should not worry about it. Just you can ignore it. Press play. You see what the robot is doing? Exactly the points which you have created, it is moving to that same location. So it is going in the forward direction and again coming back to the same place. By default, the robot will be in loop, so it is keep on repeating. But if you prefer it is not required, then you can always go to move J, again command, sorry, robo program, again command. You can see program loops forever. So this you can just click untick, again come back to the graphics tab, press play button. You can click, again take it to the first position, press play. You see now it is starting from exactly same. After reaching, it is going in the reverse way and it stopped. Okay, so which is like a one cycle completely happened. Now if you watch closely, the line which the robot is moving from one point to another, it is not at all straight. All the points if you watch closely, it is having a small bend. From here to here also you can see, and from this point to this point also you can see, it is like a very big arc kind of thing. So why it is happening? The robot by default it is taking move J. So move J is more like a it will find the fastest way to reach the destination. But sometimes we don't require the fastest distance. We need only the linear movement. So what we can do is like click this option move J. Under that you can see move L. So if you click this move L, it will change the motions into linear. Again come back here. Now you watch closely here. All the points we have created, every waypoint, it is in full straight line. There is no arc or no any bending. Again, if you want, I can zoom little more. Just observe. You see, all the points we have created, it is like in a full straight point now. So this is very big difference in terms of simulation because when you're running the real robot, this plays a major role. So again, I'm running the robot starting from the beginning. You see, now the robot is traveling full straight. Okay, again, I'll change to move J. I'll show one more time. You see, all the points got bent. Okay, it is not straight now. Again, I'm playing. Just observe how the robot is moving. Now it is not traveling straight. It is trying to achieve the point in a different way of approach. Okay. So now if you prefer to add any wait command or delay the robot, so what we need to do, there is an option called wait. Example, after reaching this right pose, I just want to stop the robot, or let it be front pose. I want to stop the robot for few seconds. Let's say I want to stop the robot for 2 seconds. You can just add wait for 2 seconds and again go to graphics tab, play. You see now what is happening? It will reach here, it will wait 2 seconds, then it will go back and it will follow the same. Okay. So this wait command is very important in most of the applications. So we need to learn that is also very important, I can say. Also, one more important thing I want to say is if you click this move J, you can see the values will be always degrees per second. Joint speed, degree per second. Joint acceleration, degree per second square. But if you prefer move L, it will automatically change to mm per second and acceleration in per second square. So why this is happening is, as I informed, move L is always linear motion, which means it will try to follow per second as a default parameter. And now if I'm changing to move J, it is actually traveling in a little angular way. So always it will try to use all the joint which can be rotated in a degree per second as a value and it will try to reach. So similarly, we have a lot of options here and it is more like a self-explanatory only. You can just try to learn by yourself and you can keep on improve yourself. And if you have any questions or any doubts or something, you can always let me know. We can discuss in the chat box or after the webinar also, you can contact us for anything. Okay. So this is the very small introduction about this particular collaborative robot simulation. And I hope it was little easy comparing to earlier if you have any experience or something. As I informed, this software is like completely free to use. You can download by yourself and you can install by yourself and you can use it for lifetime without any license requirement. So that is like a very big advantage because the same software is available in the teach pendant, but without the teach pendant itself, we are able to, without buying the actual robot, we are able to get the simulation software alone to learn the robot in detail. So this is like very important option available here. So just I want to highlight. Okay. Yeah. So I think I have completed my part. So I request Vibhuti sir just to take it forward. I'll stop my screen.
And then before we move to Vibhuti, we have a question in the chat box, if you can answer that. So, Ranveer Singh has asked, dear sir, what is the maximum payload capacity of the robot? Is it
Yes.
familiar
So
with the welding environment or requires any additional protocol with the welding process?
Very great question, I can say, Ranveer. So to answer your first question, it is actually you're asking about like maximum payload capacity of Cobot. Right now in the market, we have like maximum of 30 kg or 35 kg as the maximum payload available under the Cobot. The reason why it is like very less, if you take any industrial robots, maybe they have like up to 1000 kg also available in the market. Collaborative robot is having lot of safety parameters need to be considered. So when it is working in a collaborative space, example, human and the cobot need to work in the same place. So they need to consider a lot of safety factors. So to overcome that challenges, it is taking some time. When I started my career in 2015, there were like only three cobots available, which are like 3 kg, 5 kg, 10 kg. Now it's been like almost 10 years. We have like 15 kg, 20 kg, 25 kg, 30 kg. So these are the advantages we are having over a period of years. So it will take some years to keep on getting better. But definitely in the future, I can say like maybe we can get like 100 kg cobot also available. And to answer your second question, is it familiar with the welding environment or requires any additional protocol with the welding process? It again depends on like for how long you want to do the welding and what kind of welding you are doing. Because if continuous fumes is keep on coming from the welding environment, This robot is having IP54 as a ingress protection certification. So it can sustain for some time, but it cannot long for a long time, I can say. So it depends on like how frequently you are using in a day. A lot of peoples around the world, they are using Cobot for welding, but I don't recommend like for a full time. Example, 24 hours in a day, if you want to operate like 22 hours for welding, then it is not like very good recommendation. There are welding robots available specially for this kind of application, which is like more suitable comparing to Cobot. But again, this is again a limitation, I can say. Over a period of years, it will keep on get better. Even nowadays, few collaborative robots are having a IP67 rating also. So in that case, you can use those kind of cobots 100% for welding without any problem. I hope I answered your question. Yes. So other questions are like again very general. So what we can do is like we can complete the discussion with Vibhuti sir, then we can take it up. Okay. Thank you.
Thank you, Senthil. Can you hear me?
Yes, sir. I'm able to hear.
Okay. Thank you, Senthil. Good evening, everyone. Um, I will share my screen first. Okay, so as Senthil demonstrated how to make a simple program on a universal cobot, I will be demonstrating how to make a simple program on a ABB robot. Um, the difference between a cobot and a robot, as Senthil explained, that cobots are human friendly. Human can work alongside a collaborative robot. Same is not the case with an articulated industrial robot. These robots are much faster, can carry higher loads. Hence, it is recommended, or I would say it is mandatory that these robot always work in an area where humans are not allowed to enter. There are two ways robot can be programmed, offline and online. When I say online programming, it means somebody has to go to a factory near the robot, hold the teach pendant in his hand, and program the physical robot. Uh, Offline program is a method of programming a robot when the physical robot is not present, or it's also a very good method to learn about robotics if you do not have access to a real robot. So when we make offline programs, um, we will have to build a similar environment as the real world, so that uh, the the program that we make offline will work online. So if you can see my screen, I have created an environment where there is a robot. It's IRP 1520 ID. It's a welding special robot. Um, which has arc welding torch mounted on it. And then there is a job which is supposed to be welded. Now, the purpose of this demonstration is going to be how offline programming makes life easier who has for someone who has to teach means program a robot on site. So a program, an offline program can be created virtually here on our PCs, and that program can be used on a real robot. Before I start giving the demo, let me tell you that the software that we are using in this demonstration is ABB Robot Studio. It's it's a powerful simulation tool from ABB, and all the ABB robots. ABB has a large portfolio of robot types which with different payloads and reach available. All the ABB robots um, can be programmed using this tool. This simulation software is not free. It requires a license. So whoever wants to use will have to have a license. So in order to save time, I've already created a simulation environment, but we have a robot, there is a torch and a job. Before we start the simulation, there are two very important things that robot needs to learn. Where is the tip of my tool, which is also called the TCP? The TCP is a point on the robot tool, or we also call it the end effector. So the end effector, the part of the end effector which is going to work on the work object is called the tool center point. So there are methods to define it, but I will not keep that a part of this demonstration. I've already defined TCP on the tip of this torch. As you can see, there is a frame XYZ direction, and the origin of this XYZ axis is actually the tool center point. Similarly, another thing that robot needs to learn along with the tool center point is the work object where it is going to work. So on this table, there is a plate which needs to be welded. The corner of this, you can see there's another frame. It's called the work object. So this work object basically works as a reference for all the coordinates that robot is going to remember while making this program. So now we are more or less ready to start. We have a TCP with us, we have the work object with us. So before we start programming, we must ensure that the right tool and right work object are activated. As you can see on top, if you follow my cursor, I can select all the defined tool and work object on my um, this thing, on my screen. Okay, now there is a default template at the right bottom right. If you can see bottom right, there is a default template. So this template needs to be selected because whatever we will program, this will be programmed in this template only. Yes, we can always change it at a later stage, but it's always good to have it the one that we are going to use the most. So for the motion where we want our TCP to trace the seam between these two objects, the black object and the blue object, because we want to program it to weld the seam. So most of the motion is going to be linear motion. As Senthil demonstrated, there was motion called move J and there was motion called move L. Move L are the linear motions. I've selected move L from a large list of movement possibilities. Then there is velocity. I don't want to keep it really fast so that um, it becomes difficult to observe. Their fine points means we are going to go to each corners. We are not going to have smooth corners. We are going to have the TCP is going to go to the exact corners of this this scene. And then my tool and my work object, which I've defined, is selected. So now there are easy methods to do it when you are using a simulation software. Simulation software allows you to um, create a path with minimal effort. So as you can see here, if I click on one of the options here, it says snap edge. Snap edge allows me to detect the edge of any object. As you can see, if I'm moving my mouse, it is able to snap the edge of this joint. Now, this is very useful for me. What I will do, I will select an option called auto path. Auto path allows me to create a path alongside the edge of any object. So I want to create a path on the edge of this seam. I will simply move my mouse, select the first edge. Again, as you can see, the second edge is selected. This is also going to be a small edge, so I will select this. This is edge number 4. I'll select this. Edge number 5, and there it is, my edge number 6. So there are 6 edges in this job. I have selected all of them, and I will say create. When I say create, I'll close this now. When I say create, I can see there are targets. There are targets made. Targets is nothing but the waypoint in Senthil's demonstration. The waypoint in UR are called targets in ABB. So targets are the point where the robot is supposed to travel. And between these targets is the path. So now the targets are created, and also there is a path which contains all these targets. All we have to do is to verify whether the path is as per what we wanted or not. So is it possible if we go to any target and click and do a view tool at target, it will show me how my welding torch will look like when the robot will take it to the first point. I'm not too happy with this position of the robot. What I will do, I will select move and rotate option and select one of these and select local. Now, this allows me to modify this location, modify this target, the orientation of the robot. I can move it a little and this will this I am more or less happy with this. So I will keep it. Similarly, I have to also verify what is the orientation at other locations. So I have to quickly move the robot. Okay. And if you see the bottom here in the path on the left side of the tree, you can see there is a message in front of target 20. So target may not be reachable with current configuration. So this is something that we need to address. We can also address it at a later stage when we work on the configurations. Okay. Similarly, I will look for the again it's giving me a configuration error at come to configuration at a later stage. We'll first have to adjust the orientations. So one by one we have to see so now I have more or less adjusted the orientation. Okay, it is still giving me warning about the configuration. So there is an option called auto configuration. Simulation tool helps me to find suitable configuration for all the position, but auto configuration is not able to find a good um, good solution for me. So I'll move the robot back to somewhere and try to see can be done with the location where there is it's also possible that I simply copy one of the sorry, can copy position and orientation of one of the locations and we apply it to some other. And try similarly, we have to actually find a best path that will work for us. So most of the error is seems to have disappeared. We can use target 30. We can copy its orientation and apply it to some of the point. Then we do a little bit of rotation. So okay. So once we are sure that yes, the path is ready and there is no error, all the points are reachable, we can test the path using something called move along path. We can test the path. There was a bit of a problem with one of these. So yeah, so I mean, this is how we can program it offline. Okay, so once we are okay with the path, we can use this program in our teach panel. So what we'll do, I'll just rename my path to my path to a name that I can understand. And then whatever I've done at this station, I can synchronize it with my Rapid. Rapid is the, the program. Rapid is the programming language, also the controller version of it. So I want this program from this station, the virtual station, I want to move it to our teach panel. And simply say, okay, this configuration is completed, and now the program that I created is available on my teach panel. And if you're working on a real robot, um, will be available on the real teach panel. So it's the code, there's the module I was working on, then there is my path. The program I just made is now available on the teach panel. So this is how you can create a path using AutoPath, and then you can have it on your teach panel, and you can use it for your programs. So that was a demonstration from my side. Any questions you guys can ask? You can type your question in the chat.
Yep, guys. Thank you, Senthil. Thank you, Vibhuti. I'll help you guys. I'll just read out the questions one by one, and then you two can pick it up. Okay. So Amit has asked what type of robot is used in assembly line.
Senthil, would you like to answer this?
Yes, sir. Yeah, so there is no actual robot which are like specially made for assembly, or it is like any particular application. More specifically, I can say like any cobot or like any robot if you take, there are few exceptions. Example, painting robots, you need to be having purchased only painting robots because it requires like fire safety protection kind of things. But assembly robots are more like it is going to be along with the humans, or it is going to be inside the cage where it is getting some part need to be assembled. So we have no limitations or like any constraints where we need to purchase only this kind of robots, or you need to purchase this model only, not like that. You can purchase any general robot and you can use it for like assembly application without any issues.
Okay, I hope Amit that was helpful for you. Next, we have what is the main function of an end effector?
In defector is anything that is connected to the joint 6 of a robot, and in defector is actually the tool that performs the task. Robot without an end effector cannot perform anything. Like if I have to do welding, I will need a welding torch. Welding torch in our case will be the end effector. If I have to do metal handling, I will need a gripper. Without gripper, robot cannot perform the metal handling. So the gripper in this case will be the end effector. So it's the end effector that performs the task. Robot is something that carries it, handles it, and manipulates.
Okay, so this was from Ritesh, and he has one more question. Which actuation method provides the highest power to weight ratio for robot grippers?
But can you repeat the question?
Huh. Which actuation method provides the highest power to weight ratio for robot grippers?
So there are methods to actuate. There are pneumatic actuation. There are servo actuation. There are magnetic grippers available also. So yeah, depends on even the pneumatic grippers can give you a very good power to weight ratio. It's completely depend on the design. So a good design is the need for a good power to weight ratio.
Okay, next, Livin is asking, can we customize EO80? I hope I'm saying that correctly. Is it possible in simulation?
Senthil,
Yes, sir. So again, customized EOT is like highly possible, but again, based on the software you're using. Example, if you're using ABB robot or Fanuc robot, the simulation software is having lot of freedom where you can design your own EO80 and you can attach it in the robot. But if you're using universal robot, as I informed, this is more like a replica of the teach panel software. So we cannot actually add any external UIT or any other things. Example, if you want to add a table or like a welding torch or anything you want to add, it is having limitation. So it depends on the software, I can say. In ABB and in Fanuc, it is highly available. Both robots we are having in-house, so we have checked out.
Okay. Then Soon Kamle is asking, what is the difference between work object and work frame?
both basically are the same thing. A work object is nothing but a frame or Cartesian coordinate system. There are different manufacturers, they use different terminologies. Some called it work object, some call it user frame, some call it work frame, some even call it the base. So yeah, the terminologies are different, but the actual thing is the same.
Okay. Then Levin is asking again, how many coordination system while we are doing robot programming? I think he's asking how many coordination systems are required while we do robot program.
Uh,
So
Again,
if I can,
yes, sir.
yeah,
Yes.
Senthil, you can carry on.
Yeah. So again, this coordination system is also like from brand to brand, it is having like different names. Because in Universal Robot, if you take like we have view coordinate system, base coordinate system, also tool coordinate system, also user defined coordinate system. Like many options are there. In terms of like ABB robot or Fanuc robot, they are having like their own different names of coordinate system. But in general, if you ask me, we have like a base coordinate system, which refers robot as a base and it will try to calculate the values. Also, the other option is tool coordinate system. So, which is like where the tool TCP is exactly located. From that, the coordinate system works. The one more option is user defined, which means wherever you want to define where you want to have origin and X positive, Y positive, you can also define. So these are the general options, three options available, but in different robo brands, again, it is in different names.
Okay. In the interest of time, I'll take two, three more for the people who have not gotten a chance yet. Then we'll also give a brief about Tata IIS, so that will take 5 minutes. Rest, Senthil Vibhuti, I request if you could maybe, reply back in the chat box later to the queries that you had. So Saurav is asking, what is the formula to calculate torque at a robot joint due to a force acting at a distance?
Senthil.
Yeah. Can you just let me read the question? What is the formula to calculate the torque at a robo joint due to force acting at a distance? Yes. So this is more like we need to learn properly this kinematics and dynamics to understand what is the exact torque. Also, the motor which you are choosing, it plays a major role. Because each motor will have its own torque. When you are purchasing the motor itself, based on the torque only, we need to confirm saying that this particular motor will work for 3 kg payload or 5 kg payload. So it is actually a big question, I can say, and the formula for this, it's we need to work on like lot of mathematics to understand. But in general, as I inform, any robot you are buying, before getting the robot itself, they will do all these calculations and they will try to find the information, and then only they are able to find what is the payload it can handle. Because when they are telling like 5 kg payload robot, which means at a distance in the end of arm tool, the robot is able to handle 5 kg of payload. So it will create lot of torque in each joint. Example, joint 6, joint 5, everywhere it will create. So that torque value will be within the range. Then only the robot can able to work without any problem. So again, as I informed, like this formula is like a very big process to do, but we can do that.
Okay, thank you, Sanjay. Uh, then Raj is asking any other free simulation softwares they can practice on.
Yeah, there are very few robotics simulation software that is free. Uh, like the one that Senthil demonstrated is the UR sim that is free. Yes, that can be used. There is also something called it's not exactly a robotic simulation software. It's a plant simulation software where one can simulate an entire factory, which also includes robots. So it's called Siemens plant simulation, Siemens plant simulation. That is a free software. Yeah, there is a method. You have to register as a student, and then they will give you the license lifetime for free. That is something students can use for
Yes.
simulation.
Adding to that, just one point from my end, Fanuc is having a RoboGate software which is free for 30 days of time. We can just use it. So beyond that, we cannot use.
Same is the case with ABB Robot Studio. 30 days is free. So they can use Robot Studio 30 days, and then it will ask for a license.
Okay, great. So multiple sources are available. That's good. Then Rahul has asked three questions. I will just take one of them because we have lack of time. So, how to establish communication between multiple robots and PLC? I think someone else has also asked ki how to connect a robo with a PLC. So, this will answer question for two people. Yeah.
Senthil.
Yes, sir. So communication between multiple robots again depends on like what communication protocol you need to use. In general, we have like a default option is hard wiring, which is like digital input and outputs you can use. Digital output of robot one can be connected to the digital input of robot two, which means every time you are switching on digital output in the robot one, it will automatically give a proper input to the robot two. So this is the very easiest way, but you need to be very good in wiring that it plays a major role here. The second option is you can use RJ45 cable. Using that, if you are having like Modbus communication, Profinet communication, or Ethernet IP communication, you can just connect two cables. One cable which is having two ends, one end to robot one, the other end to the robot two. So using that communication protocol itself, you can send any information between the robots. It will work. Same thing for PLC also. If you want to connect any PLC, first thing you need to confirm is what is the communication protocol that PLC is accepting, whether the robot is having the same communication protocol or not. Worst case, as I informed, hard wiring can be always done, but it requires like lot of wirings need to be done and maintenance is like little tough. So I always prefer like you can just have a Ethernet cable connect and you can use communication protocol, which is very easy.
Okay, thank you, Senthil. Rest of the questions we'll just answer in the chat box. And we also have your contact number. And if you want us to contact you, आप अपना phone number chat में डाल दीजिए. We'll answer your query. We'll just take last 2-3 minutes to introduce Tata IIS and what courses we offer. I think one person, Salman, had also asked in the chat box, okay, what is Tata IIS? I'll just give you a brief. Um, so, श्री नरेंद्र मोदी जी हमारे जो प्राइम मिनिस्टर हैं सब उनको जानते होंगे ही विजिटेड सिंगापुर वहाँ पे एक इंस्टीट्यूट है आईटीई इंस्टीट्यूट ऑफ टेक्निकल एजुकेशन जो कि हैंड्स ऑन ट्रेनिंग और स्किलिंग कोर्सेज में बहुत फोकस रखता है एंड इट इज समथिंग डिफरेंट फ्रॉम द कन्वेंशनल एजुकेशन कोर्सेज द डिग्री कोर्सेज द डिप्लोमा कोर्सेज दैट वी डू सो वहां से उन्होंने प्रेरणा लेके इंस्पिरेशन लेकर ही वांटेड टू स्टार्ट अ न्यू ब्रांड कॉल्ड आईआईएस व्हिच इज इंस्टेंट इंस्टीट्यूट ऑफ स्किल्स जैसे आईआईटी आईआईएम्स हैं जो कि टेक्निकल एजुकेशन और मैनेजमेंट में बहुत पॉपुलर है फेमस है वहाँ पे लाखों लोगों को एडमिशन लेने की चाहत होती है वैसे ही आईआईएस की अभी शुरुआत हुई है इंडियन इंस्टीट्यूट ऑफ स्किल्स it is a government initiative, Ministry of Skill Development and Entrepreneurship backed है ये and Tata Group is helping develop the two institutes. हमारे दो campuses हैं Indian Institute of Skills Ahmedabad and Indian Institute of Skills Mumbai. So दोनों जगह we do courses in multiple sectors. जैसे कि आप यहाँ देख रहे हैं एडवांस्ड मैन्युफैक्चरिंग इलेक्ट्रिक व्हीकल्स एंड हॉस्पिटैलिटी ये तीनों सेक्टर्स में हमारे कोर्सेज ऑलरेडी चल रहे हैं to give you all a brief for technical education जो आपको स्क्रीन पे दिख रहा है हमारे पास आईटीआई के लिए 3 कोर्सेज हैं डिप्लोमा के लिए वी हैव 2 कोर्सेज फॉर डिग्री वी हैव 3 कोर्सेज एंड बिकॉज आप लोग सब रोबोटिक्स एंथुजियास्ट्स हैं पर्टिकुलरली हमारे पास रोबोटिक एंड ऑटोमेशन फॉर स्मार्ट फैक्ट्रीज एक कोर्स है फॉर 8 वीक्स दैट इज 2 months हमारा एडमिशन प्रोसेस काफी सिंपल है हम लोग आपको रजिस्ट्रेशन लिंक चैट बॉक्स में भी अभी भेजेंगे इफ यू आर इंटरेस्टेड इन एनी ऑफ द कोर्सेज आप वो फॉर्म भर सकते हैं उसके बाद आपको एक ऑनलाइन एडमिशन टेस्ट क्लियर करना होगा अगर आप वो क्लियर करते हैं तो आपको हमारी तरफ से एडमिशन ऑफर का एक ईमेल आएगा एंड देन यू कैन सबमिट द फीस आप फीस जमा करा के अपना एडमिशन कंफर्म कर सकते हैं So that was an overview from my side about Tata IIS. We have already done 2 batches. We are currently running the 3rd batch for these courses. और हमारे 4th batch के admissions चालू है और चल रहा है. So you can immediately apply if you're interested. We will also share a short feedback form after the webinar to understand कि आपका experience webinar में कैसा रहा. सो आप प्लीज अपने कमेंट्स उसमें दीजिए ताकि हम आगे और अच्छे वेबिनार्स कर पाए. And in the end, thank you all for joining, and special thanks to Vibhuti and Senthil for taking out the time to prepare for this and to so patiently explain to all the joinees. Thank you so much for taking out the time. Okay, any last words you guys want to say before we close?
Yes, yes. Thank you everyone for joining. As I informed, like it is Friday evening. Still, I can see like 30 plus people's been joined here. So I think that is a really a great effort. Really, thank you. And as Srishti informed, like after the session is over, still if you have any questions or something, you can always drop us in our email also. And we have contact number details also mentioned in the chat. So you can check and you can let us know. Okay, we are always ready to help.
Thank you. Thank you, everyone.